This is Bob McFetrich with Beckwith Electric, and I'd like to thank you for downloading our training session for the M-6200A on how to order and install adapter kits correctly. So the M-6200A is a single-phase regulator panel, and it will work with any of the existing manufacturers of single-phase regulators, which can be GE, Howard, Siemens, or Cooper. And basically the adapter kit is a bag full of parts that can be screws, clasps, magnets, brackets, and cable harnesses. And the concept is that the same 6200A can be put in any regulator once you marry it with an adapter kit. So the concept is we take the same panel and we put a different kit on depending on the manufacturer, and then that panel becomes specific to that particular regulator. So we can do this one of two ways. We can either order a 6200A by itself and then order different adapter kits, and when we need to put a panel on a regulator, we take the correct adapter kit and assemble it to the panel. Or if we know that the panel is going to go on a particular vendor's regulator, we can order the kit with the panel at the same time as an assembled unit, and then it would come pre-assembled. So you can order it either way from the factory. We're going to assume for the majority of this presentation that you've ordered the panel by itself and the kits by themselves. Typically this is done for spare parts. So I've got a combination of GE, Siemens, and Cooper regulators on my system, and instead of stocking spare panels for each regulator, I'm going to stock just a couple 6200As, and then I'll stock the individual kits. And when a Cooper fails, for instance, I'll just pull 6200A out, pull an adapter kit out for the Cooper, marry them together, and then use that. So again, the concept would be we have one panel that's universal. We have different kits that make them work individually to different manufacturers' regulators. So with that in mind, there are a couple options. The first option is going to be what we call the quick disconnect cable. So you can see this cable down here is not a quick disconnect. It is one continuous cable that has wires and lugs on either side. Where this cable, we have split it, and in between we've added a couple connectors, a white connector and a green connector. The green connector is your CT, and it has a shorting mechanism on the regulator side of it. So this side of the connector would go to the panel, and this would go to, these wires would go to the TB1 and TB2 blocks on the 6200A panel. This side would go to the regulator, in this case a Siemens plug. And the CT shorting would be such that if the panel were to fail, we can just pop these two connectors open, take the panel off, put a new panel on, reconnect these, and we don't have to mess with this end any longer. So that is the first option, is we can order a quick disconnect. To do that, we would take whatever the adapter kit part number is, in this case a B2271 for Siemens, and if we add a Q after that, that stands for quick disconnect, and that would give us our quick disconnect option. The other option is the PDS plug. This option is available only for Siemens and Howard. While the quick disconnect can be purchased for any kit, the PDS plug can only be purchased for Siemens and Howard. And if we put a T at the end of the part number, that states that we want this plug pre-wired to the harness. So if I order this harness without the T, I'm going to have the individual cable harness, but I won't have this black plug. If I order it with the T, not only do I get the plug, but these wires will already be pre-landed on the plug from the manufacturer, from the factory. So the two options that can be ordered with any of the harness kits are a Q for quick disconnect and a T for the Siemens or the Howard PDS plug. So in general, there are two terminal blocks on the 6200A itself, TB1 and TB2, where all the wires between the regulator and the control will go. There's a third block, J3, at the top, which is only for RS-485 communications. So we can see, for instance, that the source voltage is going to go into terminal 3 if we have multiple PTs. If we only have one PT, the load PT will always go into terminal 10. Motor power into 9, the return into 8, the neutral contact, for instance, goes into 16. On this terminal block TB2, the main thing we're looking at here is that we have a jumper that is vendor specific. So for Cooper regulators only, we would have a jumper between TB2, 1 and 2, but not between 2 and 5. For all other regulator manufacturers, the jumper would be between 2 and 5, and we would remove the jumper from 1 to 2. So if we're going to take that one panel out of stock, we have to remember to look at that jumper before we hang it on any individual manufacturer's regulator. Now, if the jumper is in the wrong position, it will not damage the control, but it will cause the operation counter and the tap position not to work properly. So let's start with a GE regulator. For GE, there are two different adapter kits. One kit for everything except the SM3. So we're talking the ML32s, VR1, SM1, SM2, SM2A. And then we have a separate one for the SM3. Now the kit physically is the same as far as the physicals to mate it to the regulator. So what we have is we have punch outs that sometimes get punched out, sometimes don't, depending on what panel you're hanging. So you can see in this panel we have to punch this one out because that's where the clasp is going to go. And then over here and here is where the two hinges would go. And if we were to look at it on, you can see these have not been punched out. We did not require these, so they stay filled. But we did have to punch this one out to put our clasp, and over here we had to punch these ones out for the hinge, but you can see up there, for instance, that one was not punched. And to punch these out, we would just take a screwdriver from the back side and push through the hole, and this is perforated covering. It'll just come undone, and then it'll allow you to access that hole. Now for the wiring side of the kit, this is showing a quick disconnect version of the kit, and they come in these little white duffel bags with the part number on them. You can see that we have the hinges and we have half the cable harness. The other half of the harness would be ordered with the control itself. So when you ordered the M-6200A, you would order a Q on it, and that would give you the other side of this cable, pigtail cable. Now, for the GE regulators other than the SM3, all the wiring will be done on what are referred to as the NN terminal blocks, these two terminal blocks. And they are labeled, so this would be 8, 9, 10, then 20, 21, 22, 23, 24 on the top, 25 through 31 on the bottom. And the top side of each of these blocks, these wires here and these wires here, go to the regulator itself, and we do not mess with those. But the wires on the bottom side are what actually go to the controls. So we would have to unterminate each of these wires from the old control, and then these wires would be terminated into the same blocks. And on each wire will be a wire tag that will label, for instance, NN25, to tell you which terminal it should be going to. Now there's a jumper, this orange wire in the harness, and that's because NN9 is the hot wire. But there can be 3 different PTs, one on NN20, 21, and 22. And so depending on which PT you want to feed the control, you will run a jumper from either 20, 21, or 22 over to 9. And then that's how the control will both get its power and its sense voltage. We have to be careful with this jumper because 10 is the ground. So if we run the jumper from one of these PTs to the ground instead, we're going to short out that PT and we're going to let smoke out the top of the regulator. So that's how this particular harness would work, is we would have to lift the wires, pull them down, drop our wires in, get our jumper run back where it needs to be, and we should be done. Now, the shorting is done on the older GEs via the cable at the top of the regulator coming out of the dial indicator. When you've got to pull that plug, and there'll be a little plastic black plunger, and when that plunger pulls out, that shorts the CT. If that plunger breaks or doesn't pull out, then you will have an open CT. So we have to be careful on the GE regulators. The newer regulators will typically have a knife blade in the control cabinet, much like the Cooper regulators. But on the older ones, you have to pull the plunger from external to isolate the CT. Sorry. This shows you the electricals of the same thing. Now again, it's not a GE, it's not a Cooper, so our jumper's between 2 and 5. This shows the different NN terminal blocks. And again, we're doing the wires on the bottom ends, and it'll show us what each terminal, so for instance from NN9, which is the power input, that has to go to both TB9, 1, 9, and 10. And notice we should have a metal jumper between 9 and 10. Now, the other type of GE regulator control is the SM3, and that has a existing paddle board. And what we're going to do is that paddle board will remain, but we're going to have a connection here that we're going to swap out to mate up. So, in that case, this is how it would be wired. Now, on to the Siemens. So for the Siemens, we're going to mount the hinge on the opposite side. This is where the hinge was for the GE, but for the Siemens, we're going to mount the hinges on the left. We're going to have a bracket that goes the whole way down the right, and then there'll be a magnet that mounts down here to the back of that bracket to actually keep the control in a closed position. So for a Siemens, the hardware layout is hinges will be on the on the left, excuse me. Bracket on the right with the hinges and no clasp. To look at that physically, here is one installed, and this is the long bracket. You can see right down here the tip of the magnet holding it in the back, and then you can see the hinges going into the panel here. So this is typically how it would look from a mechanical standpoint once the panel was assembled. Now the Siemens uses the plug, and that would be up here. So this one is already plugged in. The female side of the plug remains on the back of the cabinet, and the wires from the regulator go down into the top of that. And then the male side of the plug is what mates in to bring those wires down into the regulator panel. The shorting is done in the plug itself. So there's 2 wing nuts, and as we loosen these wing nuts and we pull the male side of the plug out, we're going to hear a little bit of spitting, which is the CT. But as we get it completely out, that spitting sound should stop. If it doesn't, that means we have an open CT and we need to go back in with the plug. But that is how we would isolate the CT with a Siemens. And this shows us the Siemens kit. Again, there's the plug with the wing nuts. And as you can see, it's wired to a harness. In this case, this is not a quick disconnect harness. And here is what a quick disconnect harness would look like pre-wired on the plug. So if you buy the Q and the T, which is quick disconnect with the plug, you will get both the quick disconnects and the plug pre-wired, ready to go onto the panel. And this shows the back of the panel, the bracket and the magnet and the hinges, and in this case a straight through wiring harness. And here's our wiring diagram for a Siemens. Notice we need to have a jumper on the PDF plug between E and E1. We also had the jumper between 2 to 5 on TB2. And then the following wires, and again this shows you. So for instance, the neutral light is U12 on the Siemens, and that should be wired to TB116. So if we go from U12 to TB116, we can see the wire there. And again, the wires will have termination labels on both ends so that we can inspect both ends of the wires to make sure that they are wired correctly before we energize the panel. Now, if you're throwing away an older panel, you can remove the plug and reuse it. You would just have to lift the wires off the old panel and then wire the new panel harness to the plug. But they can be reused. Alright, now we'll move on to the Cooper regulators. And with Cooper regulators, we have two different kits. One for regulator controls prior to the 6A and one for the 6A. In either case, the brackets and the physical mounting are done the same. So in this case for the Cooper, notice we have the hinges on the right. We have a long bracket that gets mounted to the left. And there are two clasps here and here that are going to fasten the panel to the back. So if we were to look at a Cooper, we can see we have the hinges here and here. And we have our long bracket here with the two clasps to hold it shut. So that's how a Cooper panel should look once it's physically wired up. Now, the difference between the prior to and the after 6A is the harness. Everything prior to the 6A has what's referred to as a fan strip. That is this connector right here. And notice this one has 9 terminals plus a ground wire. That white wire goes to ground. And this is a quick disconnect one here. But this is what we call the fan strip. If we look inside the regulator control box itself, you can see that the fan strip is down here. It's this bottom one right here. And it'll have 20 positions, but our control only goes to ground. So we only use from ground to the right, and we do not use any of the wires to the left. So when we're retrofitting this, the first thing is there'll be a knife blade up here that's not shown to isolate the CT. Next, we'll take a screwdriver and we'll just back out each screw enough that we can drop this strip down, remove the old control. Then in our strip, we're going to start with this terminal here. The one furthest away from the white wire is going to go to the DHR, the drag hand reset, and it should stop with the VS, and then the white wire should go to the ground, and the remaining terminal should be empty. And then we'll just tighten those back, and that's all we should have to do from a wiring standpoint if we have the older Coopers with the fan strips. And this shows the wiring again for the fan strips, what each of the terminals does and how it's wired back. And again, because this is a Cooper now, we do want the jumper between TB2, 1 and 2 instead of 2 and 5. And this will show the same exact wiring, only with the quick disconnect in the middle of the harness. So here we've got the quick disconnect. That's the CT, the green shorting CT connector, and that's the white Molex connector. Now for the new 6A, we replaced the fan strip with a gray terminal block, a Phoenix type connector. And again, we're only going to use the first 10. We're going to keep that jumper from TB2 1 to 2 again. So the only thing that's changing is the actual connector, where we're going from the fan to a new gray connector I'll show you in the next slide. In this slide, we're seeing the same exact drawing, only with the quick disconnect option installed in between. But this is the new, we replaced the fan strip with this gray Phoenix connector, and this is what ours would look like. So this would go directly into there, and again you'll notice that we only go to the wires up to the G, so from this point over, and we'll have no wires from this side over. And again, the CT shorting would still be a knife blade up at the top. So a -1 after the 2355 will get you the new gray harness. If we don't have a -1, then you're going to get the fan strip instead. So with the Coopers, it's always going to be a 2355, and if there's no dash, then it is a fan strip. If it's a -1, then you're going to get the new gray Phoenix that are used for the 6A panels. And this just shows you the back of a panel. So here we have ordered the panel with the quick disconnect. So you can see all the wires are pre-wired to one side of the disconnect. Then this is a new Cooper harness quick disconnect on the other side. And we would just connect these together once we hung the panel to do the terminations. And the Howard regulators are done very similar to the Siemens. So from a physical standpoint, they have a hinge just like the Siemens, but it's on the other side now. And instead of having a magnet, it actually has a clasp that you can see right here. So from a physical standpoint, it's more similar to a GE, in that we have the brackets or the hinges on the same side, and we actually have the clasp. So from a wiring standpoint, it's going to be like a Siemens, but from a physical, mechanical standpoint, it's very similar to a GE. Now, the wiring is similar to a Siemens because it has the same type of PDS plug as a Siemens. The notations are different, but the plug is the same. So we've got our jumper from 2 to 5 because it's not a Cooper. And then between the plug and each of the terminations, we have it pre-labeled on both sides of the wires. So I hope that's been beneficial in showing you why we have the different kits and how you would physically mount a kit to the control correctly, and then how you would wire it correctly to the box. If you have any questions, concerns, comments, they're always welcome. You can submit them via the web portal you're currently on. And we very much at Beckwith Electric appreciate your time and your business. Thank you and have a blessed day.